Next, we are going to focus species area relationship before. Previous class, what we discussed, that means latitudinal gradient of biodiversity. So, in the latitudinal gradient of biodiversity, we discussed the different degrees. We are from tropical regions to different regions. We are moving, automatically population decline, and so why these tropical regions having greatest biodiversity is present. That means what are the reasons? What are the reasons for greatest biodiversity in the tropics? Now we discuss later. So species area relationship we'll discuss. So, reasons for greatest biodiversity. That means the largest biodiversity you can see on the tropical region. The tropical latitudes, first one, what are the first reason? Tropical latitudes relatively undisturbed several millions of years. What is this one? The tropical latitudes have the region undisturbed several millions of years, that had a great evolutionary time, as long duration is available. Long duration is available in this region. As a result, what will happen? Here, speciation. That means new species are produced. Once again, this point. So, the tropical latitudes have undisturbed several millions of years. What are the, here we are living in the tropical regions. So, maybe, so in this region, what do you call it, is a disasters not came. So any disasters are not came means undisturbed. The climatic condition, the temperature, light, water, everything is sufficient. Everything is sufficient. The climatic conditions are supported to all the living organisms. That means undisturbed several millions of years, that had a great evolutionary time. That means what are the organisms? That means one by one organism automatically evolutionary, so much of changes are formed. That means in this situation, that had long duration is available. So much of it is duration, time period is much more is available, several millions of years. So that's what will happen. The organisms are, it is potentially inbreed to production of it is the new species. That's it. That is one reason. Undisturbed the several millions of years, that had a great evolutionary time, as a long duration is available. As a result, it is the speciation. Next, second one, the tropical regions. In the tropical regions, what are the conditions are present? What are the conditions are present? That means the tropical climates. The tropical climates are relatively constant. And predictable. Okay, so that's what will happen. So the tropical climates are relatively constant and predictable compared to the temperate regions. Okay, so here in the globe, this is the tropical region. This is the temperate region. So in the tropical region, what are the tropical region is present? So this tropical region, the climatic conditions are completely constant, stable. As a result, what will happen? Niche speciation, different kinds of the organisms are produced. Different kinds of it is the organisms are produced. Same, what are the no changes? Environmental climatic conditions are no change. If the stability is maintained. As well as when compared to temperate countries, temperate regions here. So that's what will happen. Here the new speciation can be produced. Here you can see here the tropical latitudes have undisturbed several millions of years, I said. So that's why great evolutionary time that has a long duration is available. As a result, here speciation. But here temperate region you can see in the temperate regions here the glaciations are formed. Okay, number of times the glaciations. As a result of glaciations, the what is this? What are the climatic conditions are? It is present. Everything is disturbed. The glaciations are formed during the temperate countries. As a result, new speciation production is very less. So in the tropical region, it is undisturbed several millions of years automatically. So new species is produced. Like that, it is the climatic conditions. What are the climatic conditions are present? That the climatic conditions are, it is a stable, constant and predictable than temperate regions. As a result, it is a niche speciation. As a result of speciation. Next, third one, what are the means here? The presence of solar energy. The presence of solar energy and also resources. Other resources, that means particularly water is present. So the resources, of solar energy, temperature, light, and also the resource, particularly water and land, everything is present. So that's why as a result what will happen? As a result what will happen? In the what are the organisms are present? So the plants, their productivity can be increased. What is this one? Plants, that means increasing the productivity. Increasing the productivity means food is increases such an area. Food is whenever it is in that all resources available, food is available automatically. Species diversification. Species diversification can be present. That means the distribution of number of species, variation it can be found. That means new species also it can be present. That's it. These are the three reasons behind of the greatest biodiversity is present in the tropical region when compared to the temperate region. Once again see, so in the tropical latitudes, so relatively undisturbed several millions of years, that had a great evolutionary time. That means as a long duration is available, as a result it is a new species is produced. So undisturbed several millions of years. So that's what are the organisms are present. These organisms are potentially inbreed. That means a new species is produced. Next, second one, it is the tropical climatic conditions are relatively constant and also predictable. So than temperate countries, temperate regions. As a result, what will happen? New species are again produced. And third one, it is the solar energy and also resources like water, everything is available. That means solar energy means temperature is present and light also available. Other resource means water is sufficient. Okay, that's why that means water is sufficient means there is much more land area also present. As a result, what will happen? What are the plants are present? So those plants are their productivity it can be increases. Food is increases. Whenever it is food is increases, what will happen? The greater species diversity. The greater species diversity it can be formed. That's it. So suppose temperate regions. So the temperate region you can see here the tropical region, the tropical latitudes are disturbed. Why? Because in the tropical region, temperate regions they are disturbed. This is the temperate regions. in the temperate countries. Why? Because so much of glaciations are formed. So that's why here there is no stability is not maintained. The whatever it is the organisms. It may finally it leads to death also, and also the new species production is very less. And also climatic conditions also, when compared to tropical, here temperate regions are very less, that means not stable. Okay, that means third one, it is in tropical region solar energy resources, water, everything is available, automatically population can be increases. That's it. Next we are going to discuss species area relationship. Very important of this concept, species area relationship. So what is meant by here the species area relationship? Actually, species area relationship means the scientist Alexander von Humboldt. The scientist who is that? Alexander von Humboldt observed the South American jungles. Observed in the South American jungles. What observed in the South American jungles? Alexander von Humboldt observed the South American jungles. What he observed? Within a region. So this is the area. So in the forest, in the jungle, this is an area. Within a region, that means here, not outside. Within a region, species richness within a region increase. That means within a region, species richness is increased. So what are the dots? All these are organisms. Within the region, species richness is increased with increasing the explored area. Explored area means this is explored area. What is the area is taken? This is the explored area only. So how much of it is the species richness is increased, but up to a limit. Limit means this is the explored area up to that limit. Understand what I am saying? So the Alexander von Humboldt observed the species area relationship in the South American jungles. So species richness. What is meant by here the species richness? Already I said species richness is increased. So the number of species. The number of species, an area we call it is the species richness. So what he said, the species richness is increased. Where it is increased? Within a region. What is the area is taken? The area within a region it can be increased. Not outside is increased. He was observed not outside. Within a region. What he was region is taken? Within a region only it is the species richness is increased. With increasing the explored area but up to a limit. But increasing the explored area up to a limit. Limit means this area only. Okay. So now the relationship between this species richness and area. This is the species richness. Species richness number of how many individuals are this increase up to that this area only, not outside area. The relationship between this species richness and area, how it is present. The relation between the species richness and area you can see in the angiosperms, and also birds and also bats. Okay, birds and also bats and also whatever it is, another organisms are present. So those organisms, all these are, it show a rectangular hyperbola. This based upon we can find the how much of it is the species richness is present in that area. How much of species richness is present in that area we can easily find. That means growth, how much of variety number of species are present in an area, we can find this concept based upon. Once again see, so the species area relationship. So the Alexander von Humboldt observed the South American jungles. In the South American jungles, he was species area relationship. How they find, he was taken an area. In an area, so whatever the species richness is increased with increasing the explored area, but up to a limit, that's we call it as a species relationship. So the species richness, species area relationship. Suppose for example, angiosperms, birds and bats. So whatever it is, other organisms, it is a rectangular hyperbola. So the rectangular hyperbola, these values, it will give the values. So whenever it is values is increases, so in an area it can be increasing the species richness. So within an area, species richness is how much is increased, that value can be shown. That's it. So now we are going to discuss here the species area relationship. See here diagram based upon. See the species area relationship on the logarithmic scale, it show a straight line. Okay, so the species area relationship on the logarithmic scale, it show a straight line. So in that, it is on the logarithmic scale, the species area relationship, it show a straight line. Here log s, what is the equation it show? Log s is equal to log c plus z log a. Here S means species richness. What is one? Here species richness, and Z means it show a slope of the line. Slope. How much of it is a slope? Whenever the slope is increases, what are the organisms in an area? So within an area, the species richness is increased. Okay, that means the slope of the line. Next, A means here area. So here this is the area, and also this is the species richness. Once again see, so the species area relationship on the logarithmic scale. Logarithmic scale, it shows a straight line. So that's given equation, the scientist log s is equal to log c plus z log a. So here s means it is the species, how much of richness increased, and z means it is the slope of the line, that means steeper, and a means area, c means y intercept, x and y intercept. Next, if any taxonomic group, if any taxonomic group or if any taxonomically present in the region, suppose for example Britain mainly present in the plants. I am showing only it is the next molluscas in New York. Molluscas in New York. So Britain, you can see the plants, the molluscas in New York, and birds in California. Birds in California. So this all these are taken. What they are in within a region, what is the area is taken. So plants in that area, in particular area is taken in that area, and Britain in plants, and New York is a particular area, you can see the molluscas, and California you can see particular area birds. What is the areas? How much is the area? Same area usual taken. So the Britain in plants, molluscas in New York, birds in California. So the Z here, the Z value, that means the slope of the line. The slope of the line, that means the Z value is ranges here 0.1 to 0.2. So the 0.1 to 0.2. So the 0.1 to 0.2 it is regardless. It is value, it is regardless, not countable. Next, the scientist after that is what he taken. The entire continents, is taken. So here entire continents, the species area relationship defined. So that can be graph. It have, you can see much steeper. What are the organisms? You can say the much steeper is found. That means the Z value can be ranges here 0.6 to 1.2. 0.6 to 1.2 the value came. Next, I will explain again once again. Next, the frugivorous birds. Frugivorous birds. Frugivorous birds means fruit eating birds, and mammals. Mammals in the tropical region. In the tropical region, different continents. The Z value is ranges here 1.15. The Z value is ranges here 1.15. So this is the species area relation. The tropical region, different continents is taken. In the different continents region, these frugivorous birds and mammals, how it is present. So their value, that means the area and species richness, how it is relationship is present. So they can show based on the graph. The scientists find. So here also much steeper is value, that is Z value is ranges here 1.15. That means the Z value means the slope of the line value is 1.15a. Once again, see, I will explain here the species area relationship. In the species area relationship, how it is found, the Alexander von Humboldt observed the South American jungles. In the South American jungles, so the species richness and area relationship, how it is present. So you can see here, so the species richness is increased with increasing the explored area, but up to a limit. Okay, so he was taken here the species area relationship, it turns rectangular hyperbola. That means the species area relationship means what are the species, angiosperms, birds, bats, whatever it is, other organisms. So occupying an area up to the explored area, it turns what give the value, it is a rectangular hyperbola. And also see here the species area relationship on the logarithmic scale, it shows a straight line. So it gives the formula the scientist log s is equal to log c plus z log a. Here log s, here s what it is indicated means species thickness, and z is it is indicated what you call it is the slope of the line. A means it is the area, c means y intercept. Here you can see the two diagrams I shown, only in the textbook only this diagram only present. So according to the values I shown this another graph like that. So you can see in the Britain plants, mollusks in New York, birds in California. So the species area relationship. So the species area relationship, that means on the slope of the line, the slope of the line, that means the z value is ranges 0.1 to 0.2, and after that the scientist entire continents is taken, entire continents. So the species area relationship is a much steeper, that means the z value is ranges 0.6 to 1.2. After that another scientist is they calculate the species area relationship, the frugivorous birds means a fruit eating birds, and also mammals, these two are taken. So these two in the tropical region, particularly different continents region, they observe the species area relationship. So the z value is ranges is 1.15. So this is the species area relationship, very most important. Okay, this is the species area relationship.